Ever wondered what it sounds like when a skyscraper-sized chunk of ice breaks off a glacier and crashes into the ocean? It's called calving, and it's a dramatic, powerful event. But what we see on the surface is only half the story. The real secret lies hidden beneath the waves, and for the first time, scientists have finally been able to uncover it. This discovery, made by an international team of researchers, is changing everything we thought we knew about how fast our planet's ice is melting. Imagine a giant wall of ice. At the edge of Greenland, suddenly, a massive piece splits off, falling into the fjord below with incredible force. This is happening constantly, especially at fast-moving glaciers like the Ikalaratsit-Kangerliit-Sermiat. This single glacier loses nearly 4 cubic kilometers of ice every single year. That's like the entire Rhine Glacier in Switzerland falling into the sea 3 times over. Every year, when these icebergs hit the water, they create huge waves, almost like mini tsunamis, that you can see rippling across the surface. But the real game changer is what happens next, deep underwater. You see, the water in these fjords is layered. There's cold, fresh meltwater from the glacier on top, and warmer, saltier ocean water at the bottom. The initial splash mixes these layers, but it also creates something else, massive underwater waves. These are called internal waves. You can't see them from the surface, but they can be as tall as skyscrapers, rolling back and forth between the layers of water long after the surface is calm. And this is where the problem lies. These powerful internal waves act like giant underwater spoons, constantly stirring the fjord. They churn up the warmer, saltier water from the depths and bring it right up against the base of the glacier. Think of it like holding an ice cube under a running tap of warm water. It melts much faster, right? That's exactly what's happening to the glacier. This warm water eats away at the ice from below, undercutting the glacier's edge and making it even more unstable. This process, in turn, triggers more calving. It's a vicious cycle and multiplier effect that drastically speeds up ice loss. So how did scientists figure this out? It's a pretty incredible story. Measuring anything in a fjord filled with falling icebergs is extremely dangerous. You can't just sail a boat up to the glacier face. So the team came up with a brilliant solution. They laid a 10-kilometer-long fiber-optic cable along the seafloor, right in front of the glacier, using a technique called distributed acoustic sensing, or DAS. This cable acts like a super-sensitive microphone, stretching for miles. It can detect even the tiniest vibrations, from the crack of a new crevasse forming in the ice to the rumble of a falling iceberg, and even the subtle movement of those hidden underwater waves. For the first time, they had a continuous, real-time picture of the entire system, from the top of the ice to the bottom of the sea. It was this groundbreaking method that allowed them to finally measure the calving multiplier effect and see how these underwater waves accelerate melting. Why does this matter so much? The Greenland ice sheet is immense, covering an area 40 times the size of Switzerland. If it were to melt completely, global sea levels would rise by a staggering 7 meters. That would redraw the maps of our coastlines. The massive influx of cold, fresh water can also disrupt major ocean currents like the Gulf Stream, which plays a huge role in regulating Europe's climate. This research isn't just about ice. It's about the health of our entire planet. As one of the lead researchers, Dominic Griff warns, our entire Earth system depends, at least in part, on these ice sheets. It's a fragile system that could collapse if temperatures rise too high. By understanding these complex processes, we can create more accurate models to predict future sea level rise and better prepare for the changes ahead. This incredible look beneath the surface of Greenland's fjords has given us a crucial piece of the climate puzzle. It's a powerful reminder of how interconnected our world is, and how actions in one remote corner of the globe can have consequences for us all. Thanks for watching, and if you found this fascinating, be sure to subscribe for more stories from the frontiers of science.